All right, 8th grade. This is for the students that missed or need additional help. So again, we're going to be going over scientific notation. This is part one of our mini lesson. So scientific notation is going to be represented as such. We have A times 10 to the power of B. Okay. A represents a number greater than 1 but less than 10. B is also known as an exponent also called power, but it represents how many times 10 is being multiplied by. So for instance, 10 to the first power is 10 because there's only one 10. 10 to the second power is 10 times 10. 10 to the third power is 10 times 10 times 10. Okay? Now, the goal with scientific notation is to eliminate ending or beginning zeros. Okay? To eliminate ending or beginning zeros. To make smaller. Okay? So what I'm going to focus on first in this first part of the lesson is going to be converting from standard form to scientific notation. Okay, so when I talk about standard to scientific, standard form is just going to be any regular number, a really long number. So for instance, if I had the number 12,500,000, it's going to look like this. 12,500,000. Okay? Now, it looks small right now, but when you're making reports and your numbers get bigger, for instance, in the math industry, in the health industry, in the science industry, you're not going to want to write these numbers all the time that long, which is why they created scientific notation. And again, based off of the rule of scientific notation, we're going to try and make this meet A times B to the power of 10, given those special rules that we had mentioned earlier. Okay? So converting this from standard form into scientific notation, remember our goal. Our goal was we want to eliminate ending or beginning zeros to make it smaller. So looking here, I see a whole bunch of zeros at the end. I want to try to eliminate those. Okay? So again, my goal is to try to eliminate these. So with that being said, I'm going to have times 10 to a certain power. And I did say times 10 to a certain power because in the formula, it's always going to be times 10 to a certain power. Okay? Now this number here, this is considered a whole number. There's no decimal. The decimal is actually imaginary and it's way back here. We just don't see it because, again, we don't need that decimal. So in order to write this in scientific notation, we are going to move this decimal until we make a number greater than 1 but less than 10. So I'm going to move it by hopping 1, 2, 3, 4, 5, 6, 7. Now I moved it 7 because I placed my decimal right here. Does that meet the rule? Is that number greater than 1 and less than 10? Well, 1.2, yeah, that's greater than 1. And it is less than 10. So again, remember our goal is to eliminate ending zeros. By eliminate the ending zeros, I'm going to write what was remaining, 1.25. That is our A. Now, times 10 to a certain power. Well, if you recalled, when we counted, this is actually our exponent. So that means we counted 1, 2, 3, 4, 5, 6, 7 spaces, which means our exponent is positive 7. And it is positive 7 because our zeros are on the right-hand side. So I'm going to make a little note. Zeros, right side gives a positive exponent. So remember guys, drop off your ending zeros because that's our part of our goal, times 10 to the power of 7. 1, 2, 3, 4, 5, 6, 7. Let's practice another one. Now I'm going to have 231 million. So 231 million. Okay? So for this example, again, the goal remains the same. We want to eliminate all those extra zeros. Okay? So now, what I'm going to do, I want to determine what my A is. And I already wrote times 10 because I know with scientific notation it is always times 10. So because I eliminated those zeros, I know the decimal is actually in the very back of this whole number. So starting from the back, again, I'm going to move my decimal forward until the very first number behind of it. 1, 2, 3, 4, 5, 6, 7, 8. So right now I moved it 8 spaces. Because I know I moved it 8 spaces and my zeros are on the right, it's going to be a positive exponent of 8. But then my A is now actually 2.31. And I dropped all these zeros because I don't want to have to write these anymore. Okay? Let's do another one for more practice. I'm going to take 402 billion 100 million. Okay? So remember the goal. Always get rid of the ending zeros. Ending. Not right here in the middle. Ending. So I'm going to put a little line through them knowing that I'm going to get rid of these zeros. Okay? Then I'm going to move my decimal. So let's move our decimal. We know for a fact it's way back here. Let's move it forward until we get behind the first number. Our first number is 4. So this is where my decimal is supposed to go when writing in scientific notation. So now let's count. 1 hop, 2 hops, 3 hops, 4, 5, 6, 7, 8, 9, 10, 11 hops. So because there are 11, I know for a fact it's always times 10. We hopped 11 times, which gives me an exponent of 11. But My A value, meaning the number, it is going to be 4.021. We're keeping this 0 because it's in between these numbers. It's not at the end like these were back here. So for our answer, for 402,100,000,000, our answer is going to be 4.021 times 10 to the 11th power. Let's work on another one. I'm going to take 0.0006826. Well, guys, this one's a little bit different. If you notice, the zeros are on the left. Up here, the zeros are on the right, which gave me a positive exponent. Because the zeros are on the left, over here, that means we're going to have a negative exponent. So make a little note to yourself. Zeros left give negative exponent. Okay. But it's still the same concept. Okay, we're trying to eliminate the beginning or ending zeros. Because the zeros are right here in the front and my decimal is right here, I'm trying to get rid of these decimals, or these zeros. We still are using times 10 to the 11th power. Not to the 11th, times 10 to the certain power. And now we can actually solve for it. So our A, if you notice, we want it behind the first whole number. 1, 2, 3. There's my first whole number. My new decimal goes there. So we actually have for A is 6.826. Well, right here, how many spaces did we move it? 1, 2, 3, 4 spaces. But remember, the zeros are on the left side, so -4. Okay, and we dropped off these zeros because remember, we want to take a larger number and write it in a smaller form. Another example, I have 0.00000433310. Now guys, I know if y'all were a scientist or a doctor or a mathematician, y'all wouldn't want to write this over and over and over again for a paper. So let's write it in scientific notation. We know because we're dealing with scientific notation, it is times 10 to a certain power. We want to move our decimal behind the first whole number, which is 4. So we're going from here all the way over here. Because again, we created a number that is greater than 1, but less than 10. All we have to do now is count. 1, 2, 3, 4, 5, 6, 7, 8. And because the zeros are on the left side, I have a -8 power. And then our A is going to be 4.331. I left off that 0. It has no significance. Okay. One more, and then we'll start recording our second lesson.